Okay, let's get started. Before we start using specialized map-making packages in R, I first want to demonstrate just how easy it is to make a map using data and graphing features that are native to the R package ggplot2. I highly recommend that you have some basic knowledge of the tidyverse and of the language of graphing with ggplot in order to complete this tutorial. As I record this video, I'll be walking through the code chunks in the R Markdown document that's associated with this tutorial, so please feel free to pause the video as you follow along. All right, so the first thing I'm going to do is load a few packages that will be useful for these basic maps, but also map making in general. So the first package is one called maps, and that is just a basic map making package in R. The second package will be ggRepel, which will help me later on with spacing out some labels that I'll want to add to my map. And then the final package that I'm going to add is tidyverse, which contains all of the associated tidyverse packages like dplyr and ggplot2. And this will be really helpful for the entire tutorial because we're making all of our maps using ggplot. So when we think about adding layers to a ggplot, we basically are going to be adding a bunch of polygons to outline these features of our maps and setting coordinates using an argument called coord Cartesian. This Cartesian coordinate system is the common type of coordinate system that we discussed in the introductory video, reflecting points of latitude and longitude. And we can use this type of information to kind of map different features onto the same plane. For this basic map, we're really only using stuff from ggplot2. These are maps that you can make exclusively using the tidyverse. All right, so I'm on my first code chunk, the one that starts with get USA map data. The first thing I'm going to do is use the function map_data to extract a map of the United States. And I'm going to save that as an object called USA map. So if I execute that line of code and look into what this data frame actually looks like, I can see that I have 7,200 or so observations, and I have a selection of 6 different variables. So I have one called long, one called lat, group, order, region, and subregion. The really important things that you'll want to focus on here are this long variable and the lat variable. Long reflects the longitude of each of these data points. So if we think about our map as a 2D map on an intersecting XY plane, this would reflect our x-axis. And the lat variable reflects the latitude of each data point, which would be the y-axis. What we can do is use these variables within a geom polygon to plot the shape of the United States, essentially. So if I go down to the next code chunk in the markdown, I'm going to set up a basic ggplot statement. So I have ggplot first, and then each layer that I'm adding to the ggplot, I'll add using a plus sign. So to my basic ggplot, I'm adding a geom polygon, and I want to specify that my data is coming from the USA map, and I want to define my aesthetics. So this is where I'm defining what's being plotted on the x-axis, what's being plotted on the y-axis. In this case, my longitude data points are plotted on the x-axis, and the latitude are plotted on the y-axis. I'm also going to add the coord Cartesian argument to this ggplot, which is basically going to tell ggplot, hey, I'm using Cartesian coordinates here, so please adjust the map accordingly. So it's a pretty simple map to put together. And if we execute that, you should see a map of the United States plotted on kind of a gray background that appears. So that's our first map. That's how easy it can be to make a map in R. But if we think back to some of these principles of cartography, the shape of the United States is not really telling us a whole lot. But we can think of it as a good base to add some other data to. So for example, what we can do is add data reflecting the location of capital cities, so each state's capital city. Since we only have the contiguous United States plotted here, what we're going to do is exclude Alaska and Hawaii's capitals for now, just for the sake of ease and this illustrative example. So we'll start and use our first specialized map package called maps and just extract a data set called US cities. So again, this is not specific to a tidyverse package. We're just extracting data from here, but everything that we're building in the map otherwise is from the tidyverse. So from the maps package, I'm going to get the US cities data set and just look at the first few rows of that data set to see what I'm working with here. So I can see that I have names of cities, country.etc, which is actually just containing the 2-letter state code for each of these states. I have a population value, I have latitude, longitude, and I have a variable called capital. 0 is indicating that it's not a state capital, and 2 is indicating that it is a state capital. So we can see that this data set has the same latitude and longitude variables that our map uses. So that makes our lives really easy. As you'll see, if you start making maps, this is not always the case, and we'll find that that's something that we'll have to add into our data a little bit later. This data set also has this binary tag noting if the city is a state capital or not. So we can use this tag to only include capital cities in our data set and exclude Honolulu and Juneau, which are the capitals of Hawaii and Alaska. So what I'm going to do is create a new object called capitals, and I'm going to use the subset function from this US cities data set that's native to the maps package. And I'll tell R to only include cities that are capitals, so that have a value of 2 in this capital variable, and that I don't want any cities from Hawaii or Alaska. So if I run that and look at my new capitals data frame that I've created, I can see that I have 48 observations of these 6 variables, which makes sense, checks out. We have 48 states in the contiguous US. So we have these 48 state capital data points now, and we can overlay this onto the US map shape. And what I'm going to do is specify these points should be plotted in white just to contrast them against the default polygon background color. So to the same ggplot that we started off with, I'm just going to add another geome, this time a geome point, and I'm extracting data from this new capitals data frame that I created, again, specifying the same longitude and latitude variables that are now coming from the capitals data set rather than the USA map data set. And I just want to specify that these points should be white. So putting that all together and running that chunk of code, I now see 48 points appearing on my polygon shape. So this is great. We have definitely improved this map a lot already because we've added some information and we've started building a story about what we want to tell with this map. So unless you're an expert in state capital geography, it's not actually that easy to tell which cities these points are referring to. So we can improve this map even further by adding some labels. And because we don't want to overwhelm this map with a lot of information, what we can do is select our top 10 capital cities by population, for example. So in the next code chunk, I'm going to create a subset of my capitals data frame, and I'm going to use a function called slice max, which basically tells R to take the top 10, so this n equals 10, and I want to take the top 10 by population. So I'm using this pop variable. So once I run this chunk of code, I should create a new data frame called pop, which will only have 10 observations, and it should contain my most populous US state capitals. So if I run that chunk and look at the data that's printed out, that's exactly what I see. So I have my top 10 state capitals, I have the state that they're in, I have their relative population, I have the latitude and longitude of these state capitals, and I just have a double check that yes, indeed, these are all capital cities. with my 2 in the capital variable. So we can use this new subset data frame that we created to actually create labels on our map. And we're going to use one of my favorite geomes to add labels using one called Geome Label Repel. And this will basically draw a rectangle underneath the text and make it easier to read. And it will repel the labels from the data points and each other to ensure they're not overlapping too much. So again, we have one new geome being added to the map that we're slowly building. And I have that geome label repel added, now extracting data from this pop subset. So this is that data frame that only contains my top 10 most populous US capitals. As you can see, we have our same longitude and latitude variables, and this time we have a label specified. So I'm pulling the label for each of these labels from the name within my population or pop data frame. So if I run this line of code, I now see that I have, run this chunk of code, I should say. I now see that I have 10 different labels near to where each of these cities are actually located. But again, because we have 48 capital cities plotted here, it can be a little difficult to tell which data point our label is actually referring to. So we can now leverage color to make it clear which of these data points reflects our most populous capital cities and which are just our regular old, not super populated capital cities. So what we can do, and I've now moved down to the code chunk that starts with note our top 10 in the capitals data frame comment. So what I can do is create a list of these names of our top 10 cities. And using that list, I can create a new variable in my capitals data frame that denotes whether or not that city listed is in the top 10 or not. So for those that are not in the top 10, I'll say they get a value of 0. But if they are in this list of top 10, they'll get a value of 1. So if I execute this line of code and look at the first few rows of my capitals data frame, we can see that I now have a new variable called top 10, which denotes that, for example, Atlanta and Austin are 2 of the capital cities that are in my top 10. So I can use this new top 10 variable to color the data points based on whether they are a top 10 most populous capital or not. So this will look very similar to the line of ggplot code, the lines of ggplot code that we had in the previous chunk. But in this case, we're now adding a color specification to our geome point, and we're specifying that the color should be determined by the top 10 variable. So I'll execute this chunk of code, and we can see that now our variables, now our capital cities that are not in the top 10 in terms of their population are colored this kind of salmon pink color, whereas our cities that are in the top 10 are colored with blue. And we have a nice little legend that's appeared to denote what the color is actually reflecting from the data. Okay, so we're really close to kind of having a fully customized plot that kind of brings the whole story together. So the final couple of things that we can do to make this a more interpretable plot is changing the size of these plotted points to show relative population sizes, customize the spacing of our city labels, include some new colors, remove the kind of ugly gray background and legend, and add a title and caption to add a little bit more information about what this map is showing. So this final chunk of code where we customize and finalize the plot, this is a lot of like where the creative freedom comes in. So a lot of the choices that I made in this tutorial may not be something that you might make. And so I think this is our first example of taking these examples as taking them with a little bit of a grain of salt of this is a way to do it. It's not the way to do it. There's no like one right way to make a map like this. It all comes down to what you're trying to convey and what your personal vision for the map is. So for me, I've gone ahead and done a little bit of editing in here. So I've specified that I want my labels to match the color of my point. So I've used this kind of teal color to make my labels have a nice little teal outline and text color to kind of match the points. I've changed the kind of salmon pink with more of an orange to complement the teal. And then I've also used an argument called theme void, which just removes any sort of like axis and background information from the plot because we're making a map. We're not making a chart to show this type of information. I've also added a title, so I'm calling this Top 10 US Capitals by Population. And I've added a caption just to make it clear where I'm getting my data from. A lot of times you'll see people who are making maps, they don't cite their data. It can be really frustrating to see a really cool map and wonder, well, how did they get that information? So it's always great if you can share the data source, especially for any sort of open map making community that you might be sharing this with. The other final thing that I did was change the size of my points to be relative to the population of that city. So the cities, the capital cities that are the biggest will appear as the biggest points, and cities that are smaller in population will appear as smaller points. So it's a little bit more of an overwhelming looking set of ggplot code, but if I execute this entire chunk, I can see that I now have this really nice kind of isolated shape of the US. I have these orange points for my capital cities that I'm not focusing on. I have this teal and some nice dodging happening that really clearly denotes which points refer to which cities. And I have a nice clear title and I cite where I got my data from. So we've made our first customized map in R, which is really exciting. But as you'll come to find out, if you are like, wow, this is so cool, I want to make something like this, or I want to make something like that, you'll find that there are really a lot of limitations to what we can do with the data sets that are saved in R packages and with packages that aren't super specific to map making. So as we move forward with this tutorial, I'm going to highlight a few different types of maps that we can make using a variety of really specialized geospatial and cartography packages. So across the rest of this tutorial, we're going to use some different data sources and approaches. So the first section that we'll go through that's more of advanced map making, we'll be using data from OpenStreetMap. The second section will be using open source geospatial data from the Swiss government. And then the third section of the tutorial will cover elevation data. And one thing that you'll find in the rest of the tutorial, we're going to focus on a different country for the remaining examples. We're going to focus on Switzerland instead of the United States.